Welcome back to our series on induction motors. Today we are going to be talking about overload protection for induction motors. So what is overload protection? Isn't that what breakers do?
Well, the function is different, similar, but very different.
So is there an opportunity for electrical designers with overload?
Definitely. Electricians deal with overloads every day, and they know all about overload protection for motors. But designers and electrical engineers typically don't deal with this. They know that they're there. Maybe some of them know it, but it's the electrician that actually has to deal with the motor overload and install the overloads and get them sized correctly. So this is an opportunity for designers who don't regularly get their hands on a motor starter to actually understand what's under the hood of a motor starter.
So explain more what an overload protection is.
Overload protection is an attempt to protect the motor and the load that the motor is serving from very small increases in current, as opposed to what a breaker does that protects against large overloads. You got to remember, an induction motor is typically protected by a circuit that has, upwards of 250% rated breakers. So the breakers are so oversized to allow for inrush current that they are not very sensitive to small problems downstream in the motor. And so if the motor starts to get a little overloaded, the breakers upstream aren't even going to notice. And they'll just let the motor continue to be overloaded and, either burn up or catch fire, whatever that is. So the overloads are a more sensitive control of protection.
Does the overload protection also protect the conductors?
Well, indirectly, yes, because if you get an overload in the motor, it'll trip out the motor and, consequently protect the conductors. But that's not the main purpose. The breakers upstream of the conductors are intended to protect the conductors.
If designers are not involved with overload protection, what are these devices and where do they exist?
These devices are little bimetallic elements that when they have current running through them and there's too much current, they get hot and they change dimensions and they open a contact. And they're located usually in the motor starter down below the contactor. And it's an interesting fact that the main difference between a contactor and a motor starter is the overloads. A motor starter is basically a contactor that has motor overloads integral to the unit. A lighting contactor doesn't have overloads. It's a completely different animal. But a motor starter has the overloads, and that makes it a motor starter.
I've heard the term heaters with motors. Is that related?
Yeah, the slang term is heaters, and they're called heaters because that's what they do. They heat up, open up, and protect the motor. And so electricians in the field will often refer to, we got to put the heaters in and get them sized properly. But they're also talking about the motor overloads.
How hot are they allowed to get?
Well, typically an overload is sized so that when the current gets about 15% above the running current, they trip. The 15% is not a hard and fast rule, but it's often a starting point.
You said running current. Why not FLA?
Well, a motor is stamped with a full load current, but oftentimes the actual load brake horsepower of the motor isn't the same as the rated brake horsepower So what you want to do is you want to protect against the actual current. So if a motor is running at like 3/4 of its capacity, its current is going to be significantly less than it would be at full load. And so you don't want to wait until the motor is so overloaded that it gets up to 15% over full load current. You want to catch it 15% above its normal running current so that you actually see when there's an anomaly going on. And that's why we have to measure the current. After everything's done and tested and running properly, the electrician will measure the current and size the heaters or the motor overloads in accordance with what the actual current is.
How is an overload wired?
The overloads, well, there's two parts to it. The main conductors of the motor go through the heaters, and they're very low resistance, and they have virtually no effect on the performance of the motor, but they have enough resistance that they can get hot when the current gets too great. And then they have contacts, and these contacts are then in series with the control circuit of the motor, so that you can wire these contacts in series with whatever motor circuit, control circuit wiring you may have.
I noticed that there's only 2 overloads for a 3-phase motor. Shouldn't there be 3, one for each phase conductor?
Well, interestingly enough, that's what I was going to say in this podcast. And then I started looking up online diagrams for samples of overloads. And all the diagrams had 3 overloads for a 3-phase motor. Now, 60 years ago, when I was studying this, I was always led to believe that you had 2 overloads for a 3-phase motor. Basically, it was N minus 1. However many conductors went into the motor, you only needed N minus 1 overloads to actually know if there was a current overload, because the current, any overload in one wire has to get back to its source somehow. So if you have an overload in one, you know the overload in the other. And a single-phase motor just has a single overload. A 3-phase motor typically just had 2 overloads. And then I see these diagrams, and they all have 3 overloads, which is contrary to my understanding. And so I'm hoping somebody listening to this podcast can write back and say, in their experience, yes, there's only 2, or no, it's always 3, or maybe it changed in some year. I don't know. Anyway, we would love to hear some feedback from people who are out in the field actually installing motor overloads.
All right. If you have that feedback, go ahead and leave a comment on this video and let us know what you've seen in the field.
All right. I look forward to hearing back from someone who knows what's actually out there.
Let's review what we talked about today with overload protection.
Overload protection is the protection of the motor and its consequential load to have a very sensitive awareness of when the motor is getting slightly overloaded, as opposed to the breakers that are protecting the circuits, which have a very coarse view of overload. In other words, the overloads would have to be, extremely high in order for the breakers upstream. So to provide fine protection, overloads are included in the motor starter. The overloads are physically located in the starter, oftentimes just right below the contactor. And the heaters that go in are typically sized for about 15% over the running load current as measured in the field in real life conditions. And note that a contactor and a motor starter are basically the same thing, except that the overloads are part of a motor starter. And that's the lesson for today. Please let us know how many overloads go in a 3-phase motor typically, 2 or 3. Thank you.